Hello everyone, here is lecture 6 on Introduction to Quantum Mechanics. This lecture we will discuss on free particle wave function. Here is kind appeal for ignorance of alignments. Now let's see solution of Schrodinger's equation for a free particle. If a particle of mass m, capital E, energy and potential energy V is given, then the time independent Schrodinger equations will be expressed by this equation. Since particle is in free motion, because of potential energy will be 0 and therefore it will be equal to this term, where this term nebula square means gradient square is equal to del square upon del x square plus del square upon del y square plus del square upon del z square. Therefore by substituting that value here we have these three terms by adding the remaining one. So this is the Schrodinger's equation in three-dimensional case for a free particle. Now we have to calculate this one to get the solution. That solution will be a wave function. So that will be the function of x, y and z. Since on left side there are only three variables, because of the solution will be as a function of x, y and z. Since we don't know what is the solution, but we know that this function, means the solution, will be the function of x, y, z. So because of we considered previously, the solution of that one will be equal to this one, where these are the functions. Three factors are functions respectively to x, y, and z. Now we need to calculate this one. So because of there is need to substitute this one in this equation at place of psi. So when we substitute this value in each term, we will find that here x, capital X, it will be operated by del square upon del x square, and here outside the operator del square upon del x square is an operator, differential, second order differential operator. So y, capital Y and capital Z will be outside of this one. Here x and z will remain at outside, capital Y will be inside, similarly capital Z will be inside, and the outside capital X and Y. Here x, y, z will remain. Now by dividing with this term through each term, then we will have, since here in the numerator already y and z were present, so when we divide by x, y and z, then here y, z will be cancelled with the numerator value of y, z. Then only will remain capital X, 1 by capital X. Similarly here x and z terms where they are, where here as a factor will be cancelled out with x and z term on the denominator, and only capital Y will remain here. Similarly 1 by z we will have, means finally we will have this kind of equation. And here when x, y, z is divided with this term, here in the numerator already where x, y, z present, so the term will be cancelled out and we have only psi will not appear here. First term to the function of x, second y, third to the function of z. Now let's try to solve this equation with variable separation method. So for that one, we will keep x on one side, and the terms as a which is a function of x kept on one side, and the remaining terms on other side, and both are equal. But as well as we know that left side is a function of x, on right hand side is a function of y and z, and are equal. How it is possible? It is possible when both left term and right term as a sum of its different terms must be equal to a particular constant. That means if this is equal to a1 this will also be equal to K1. Then these two terms will also be equal. So by following that one, we kept here, okay, and obtained two equations. Finally, we have two equations, this one and this one. By the solution of this one, we will have capital X. Now, see this one. On left side, this term with a function of y, this term with a function of z. We will kept a term which is a function of y on left side, and the remaining term, see, it is brought on right side, it is kept on left, then it will be minus K1 and it will be positive. So it will be here single term, this term will come on this side, it will be minus, so minus, okay, this one. So now on left side with a function of y, on right side with a function of z, and both are equal, then both may be equal only when this will be equal to a constant, it will also be equal to that constant. So again we have equation 5.6. By simplification of this one or by solution of this one, we will have y which will be capital Y, which is the function of small y. Now see this equation. Again, it will be kept on left and the remaining terms will be on other side. So it will be kept on this side, it will be positive. Okay, minus is here, then it will be positive, that is kept here, and it brought to the left, then it will be minus. So minus K1 minus this one minus K2 means this one. Okay, when it is brought on right, converted into this one, when it is brought on the left, then we have this one. Now both are equal. Again both are equivalent to the next constant, any other constant, K3. Then by equating each term to that one, we will have this will be equal to this one, this equation, and when this will be equal to this one, we have this one. So now by simplifying this one, kept K1, K2, K3 on a side, then minus K1 minus K2. When these two terms brought on right side will be positive, that is kept on left here, and on the left here minus 2m upon h bar square e. This remain, so that is kept on right side. This equation is off. By solving this equation, we will have z with a function of small z. Okay. Now since E is analyzed in three-dimensional case, because of E will be equal to EXI plus EYJ plus EZK. Therefore, by splitting of that one, since K1 was equivalent or was considered for small x, when a term was taken which was the function of x. Similarly, K2 was taken when the function of y was taken. Similarly, K3 for function of z, because of K1 will be equal to minus 2m upon h bar square ex, and this term will be equal to dy, this term will be equal to dz. So we obtained K1, K2, K3. Now by substituting the values of K1, K2, K3 in the equations obtained previously, in this equation K1 and K2 will be substituted here and K3 will be substituted here. So when we substitute these values, then we will have the C for y. When K2 is substituted here, then this term will be kept here, minus 2m upon h bar square ey, and it is brought on the left, then it will become plus 2m upon h bar square ey, capital Y will be multiplied over there like this one, capital Y is multiplied here. This term was kept on left side, C on left side, and 1 by y was there, so that is multiplied here. So we obtain this equation. Similarly, we will have this equation and this equation. So we obtain three equations. the general solution of these equations will be for x1, for capital X, which is a function of x, will be of this kind, where square root of 2m ex is taken, h bar is kept here, x minus x naught, and x is taken here as a factor. Similarly, we will have a solution of this one, y this manner, for this one, where nx, ny, nz, and x naught, y naught, z naught are the constants. So now by substituting these three values in this equation, we will have the solution. So substituted here, these three values here, nx, this one, ny, and this term here, nz, this term here. And as a product of nx, ny, and z, we kept here capital N. So this is the solution of the previous equation. Let's see the next one. See, we have already been discussed about E with the sum of Ex, Ey, Ez, and capital E is obtained, which has already been mentioned in the previous one here. So, and this term is equal to this term, we are cross multiplying, minus h bar square will be here upon 2m. And these three terms will be in a parenthesis, means bracket. So E will be equal to minus h bar square upon 2m, and within a bracket k1 plus k2 plus k2. Means energy can be obtained. Since here assigned functions are single valued, finite, and continuous, because these all will also be single valued, finite, and continuous, and hence it will also be. And again, E will also be single valued, finite, and continuous. Now here the solution in terms of a function, which is only the function of position coordinates. Now let's talk about the general solution, in which the function of time will also be included. So here this term will be multiplied, the first term, a term which is a function of y, this term will be multiplied, and for a function of z, this term will be multiplied. So Ex, Ey, and Ez as a function of time are kept here as a factors. So by keeping all these terms at a place, we will have e power minus I, Ex, Ey, and Ez will be added, t upon h bar, okay, and the remaining terms kept in front. Again, the sum of these three terms is expressed as an energy. So finally we obtain a general solution for a free particle motion. So here psi x, y, z, t is representing a general solution. In the previous one, it is also a solution, but only with the function of position coordinates in three-dimensional case. But here the time is also included. If it is not needed, then it must be kept not need to be included or kept silent. Okay, this t will be 0 means when it is not a function of that term, then we will have only the values belonging to the position coordinates. So it is a solution of free particle. Thank you all.